Welcome. We are doing our capstone project on Doosan Bobcat, which is located in Wahpeton, North Dakota. I'm Jared Jukich.
I'm Jake Simicik.
I'm Justin Ebnet.
So for our agenda today, we're going to be talking about the company history, our project statement and scope, objective and deliverables, approach, and accomplishments. The Bobcat Company is an industry leader in design, manufacturing, marketing, and distribution of compact equipment. Bobcat has deep ties in North Dakota that started in 1947 and has grown to be the state's largest manufacturer with 3 North Dakota production facilities. In 1962, the Bobcat name was first introduced and became a renowned brand for its durability and dependability. And in 2007, the Bobcat became part of the Doosan family. The Bobcat facility in Wahpeton manufactures hydraulic cylinders and valves used in Bobcat loaders, excavators, and attachments. The Wahpeton facility manufactures a total of 125 different types of hydraulic cylinders and 18 different types of valves. The manifolds that we are focusing on today are the 5 that you see below, which is the second aux, the Bobtac, and power exchange, 2-speed with brake, and the standard. And those make up 80% of the manifold production.
All right, and then for our project, the project statement is to improve efficiency and flow of the manifold assembly line process. And then the work that we are considering to be in scope includes map the current manifold process for all products for the assembly line, evaluate the current manifold process and identify areas of improvement, then to create an in-depth ROI and project justification document. Then the work we have for in consideration includes discuss the possibilities of work shift changes, moving equipment in a new layout, creating new standard work if process changes are implemented. Then our out of scope includes purchasing new manufacturing equipment and changing the mechanics of the process. Then our objectives for this project include optimize operating procedure through analysis and modeling, increase overall efficiency through time studies and modeling, and then document entire process, including process mapping. Then our deliverables for this project include our statement of work completion, create a process flow map, establishing time studies and analyzing the data, develop an in-depth return on investment document, present findings and start implementation, and then finally finish our implementation. Then while completing this project, we needed to develop some assumptions to help simplify our project. And our first assumption that we had was test data we received in January can be used to represent a year in terms of cycle times and pass fill rates. Next was while doing time studies, the day shift cycle times can be used to represent the night shifts. Then the operators work similarly in terms of cycle times. And our last assumption is we only took data for the top 5 manifolds produced and assumed that the data we gathered can represent other manifolds in production as well. And next we have a process flow map. We have the 5 stages of the manifold assembly line process. First, starting with the honing, then it goes to brushing and washing, and then plugging. Next is the assembly, and then finally the hydraulic tests. And then within these 5 stages, we have the average cycle times for each of the 5 manifolds. And then for each of the 5 manifolds, the average cycle time for manifold was around 12 minutes and 6 seconds. And then for our data collection, this was the imperative first step in reaching our objectives, and we did that through many methods, including time studies, testing log analysis, interviews, general observation. Then through this data collection, we can apply numbers to our simulation, create formulas to maximize efficiency of testing, establish outcome of workstation ergonomic changes, and recognize general improvements that could be made.
So for our ergonomics, so for the workstations, we want to recommend a sit-stand stool for fine motor skill stations, non-slip floor mats, and larger wheels for the carts. So the non-slip floor mats, there's a lot of hydraulic fluid that gets everywhere, and it's a lot of oil, and it gets really slippery. A lot of the floor mats that they have right now reduce the stress and fatigue, but they're also non-slip, so that could be a safety issue for some of the workers. And for the carts going around, they have a standard 2-inch cart wheel diameter, and we recommend larger wheels so employees and operators can actually easily get the carts filled with heavy manifolds up and over those floor mats much more easily. And for power tools, we recommend using textured rubber handles to provide a better grip, to reduce fatigue, and to reduce the effort needed to use the tool effectively, and also to prevent it from slipping out of the hand. So for the sit-stand stool, the workstation design for one of the stations called plugging is inefficiently designed for precision work. A lot of industries use sit-stand stool as they relieve back pain and reduce bodily stress over the course of a shift, which could be up to 12 hours. And operators can be much more precise and accurate using the correct height of the workstation, which should be 43 inches for precision work, and by having extra support to reduce fatigue. The cost for the sit-stand tool is between $200 to $400. So justify spending $200 to $400 on the sit-stand stool. Workstation designed for ergonomics can actually improve productivity and efficiency by up to 20%. And also, if the sit-stand stool is implemented, it could save a maximum of $3,370 a year, assuming a 20% efficiency improvement. This cost saving is in terms of cycle time and non-value added time reduction. The cost of the average sit-stand stool is $200 to $400, so the ROI could potentially be 1.5 months. And in the next slide, we are going to see the graph. We actually will show you the return on investment.
So the next big thing we did for this project was to maximize the testing efficiency. So doing this, we use cycle time, operating cost, pass fail rates, and scrap rates. And with those, we were able to determine the most efficient number of tests to run on each manifold that is yet to pass. So this all has to do with the last station in the manifold assembly process, which is the testing station. And these figures were put into a formula in Excel and solved minimizing the total cost. And doing all of this, it gave us an ideal testing number of 2. So using data from the testing log, we found first that the probability of passing the test given a number of attempts, and this gave us a formula for the pass or fail rate R and the given number of tests, or given the number of tests N, and our formula is below. So first, cycle time was gathered from the testing logs, and that was found to be 4.5 minutes, and that was given in our formula as E. Operating cost was found to be approximately $42.50 an hour, or T, and that was found by adding the cost of labor, power, and hydraulic fluid. Then scrap cost was estimated to be $20, and that was given as F. So for scrap cost, we were given somewhat of a range of numbers, and so we just basically decided to pick 20 as a happy medium. And these figures are all easily adjusted, so if there's changes to the process, or if Bobcat decides that there's inaccuracies with any of these numbers, they can make adjustments pretty easily. So these figures were used to find total cost, which is represented as TC, and TC is equal to T times N times E plus R times F. And then total cost was minimized using N as a variable, and again, N was the number of tests. So for this specific manifold, N was equal to 1, and total cost was equal to 8.913. But overall, for all of the manifolds, 2 was our optimal number of tests. One of the easiest recommendations we can make after doing this testing efficiency maximization is to not test manifolds that have already been passed. So basically, if a manifold gets the green light, it should go right to shipping, but for some reason we found that some manifolds were being retested. So in an example of this was out of our sample size of 210 tests, 33 had already been passed, and there's no advantage to this. Eliminating this double testing could increase efficiency by 18.6%. And this could save Bobcat $500 per 1,000 tests, or approximately $5 an hour. If testing is done 10 hours a day, this would save the company $12,500 every 250 working days a year. Our next recommendation that came from this was only testing a part a maximum of 2 times. Given the numbers taken from the same sample in which the testing rates were found, 201 out of 278 parts were tested the correct number of times, and the other 77 parts costed the company an extra 13.9%. This number is highly determined on scrap, however, so if that number is wrong, that 13.9% will change a lot. This improvement saves the company approximately $1.24 per part. And over 1 working year, assuming 250 working days and again 10 hours running time, this could save the company $31,250. But just an example of how determinant on scrap cost this is, if the scrap cost is $50 instead of $20, the cost saving drops down to $12,500 a year. So an overview of our recommendations, the first most simple thing would be adding rubberized textured grip to power tools to reduce fatigue, increase accuracy, and improve productivity. Next would be implementing a sit-stand stool at the plugging station, which would reduce fatigue and again, increase accuracy and reduce cycle time. Next would be higher supervision and training of the operators involved in the testing process to ensure that products that pass are not being retested, because there's no advantage to that, there's no cost to that. Finally, we recommend that you only test a manifold 2 times to reduce non-value added time and reduce operating costs. So the maximum cost savings that we would predict Bobcat would see would be around $34,000 a year. So just to recap, we gave you a company history, went over our project statement and scope, our objective and deliverables. We described our approach and then some of our accomplishments. And that's all we have for you today.